Hello, my name is Tomctutor, that's me. I'm going to today do the third part of the differential of the inverse functions. The previous two videos we showed how we did a generic method given that the function stated already was an inverse function like arc, cosine, arctangent, etc. But here we've just got the function, we don't explicitly have the inverse function, but we still have to differentiate it. So this is the other method I alluded to in the first video, and this is an example of it. So how do we solve this problem? Well, here what we do is we invent, well, we have to find out, I was going to say derive, but that's bad language when I'm doing calculus. We have to get the inverse function before we can solve the problem. Well, the inverse function here is just simply 1 over a times the arc cosine of x. Now you might say, well, how did he get that? Well, I took the arc cosine of that and just divided by a, and that returned x. Remember, the inverse function is defined by g of y is returns x, where y is essentially your f of x. Okay, and when you reach this stage, when you've sort of obtained the inverse function, you should maybe do just a quick check here that when you put the function in here, this cosine a of x into here, indeed you return x like that. I'm not going to do that because I know that this is the inverse function here. Okay, so how does that help us to solve this problem? Well, here's the secret in doing this, and pay close attention. Right? If I multiply AG like that, and then take the cosine, I am going to have x. So that implies that. Okay? And what I do now is I differentiate both sides with respect to x. So I get d over, oops. So I get d over d of x of both sides here, okay? So here I have from the chain rule, because remember g is a function of x, so I take the a out, I differentiate the cosine, and that will give me minus sine ag. And then by the chain rule I have to differentiate this function of g, which is just simply g dash x, and that's exactly what we're looking for. We're looking for the differential of the inverse function, and that's that there. And of course, by differentiating the right hand side, we have equal to 1. Okay, so that gives me the answer. The g dash of x is equal to 1 over minus a sine ag. Okay, but what is, that's in terms of the function, we need it in terms of x. But from this relationship here, I know that sine ag is equal to the square root of 1 minus x squared. Okay, because cos squared plus sine squared is equal to 1, etc. So hopefully at this level you can sort of do these trig identities like that. So that's note that. So that gives me my final answer. The g dash x is equal to min 1 over a times the square root of 1 minus x squared. And that is the answer to the problem. So really the heart of answering this type of problem by using this method, remember we're not given the inverse function initially. We have to work it out before we solve the problem, unlike the previous cases. I must emphasize that. We can use this technique to establish our answer. This sort of concept here is to write x in terms of the function and then differentiate it, and that will give you the answer. So you may have to go over this a few times. It is a bit tricky. So thank you. Bye.